contextual bindings with Ninject, which allows you to bind to different types based on parameters passed into Ninject. Today we're going to switch gears a little bit and talk about binding behaviors in Ninject. Now, what binding behaviors allow us to do is to determine the object's lifetime, essentially, when we request a type from Ninject. Now, in order to define these, we use the using statement in Ninject's fluid interface. By default, Ninject is going to use what's called the transient behavior. We'll find that. So we have to import the ninject.core.behavior namespace. So we'll go ahead and do that. And actually, I want to define this in a generic method. So now we're defining this as a transient behavior. So we haven't actually changed this line. We're just explicitly stating now that we want Mountain Dew to be returned as a transient, which means that for each time we request the iCaffeinated interface, a new instance of Mountain Dew is created and returned to us. We can also change this to a Singleton behavior. And what Singleton behavior does is it returns a single instance of Mountain Dew for the entire application. So in order to go ahead and show you how this is going to work, I first did a little bit of refactoring, and I created something that I call the Ninject factory. So here you'll see, just say Ninject factory, import the namespace, and say get Ninject kernel. Now, all this is doing is allowing us to create a single custom kernel, and custom module, and standard kernel, and return it back. And each time we ask for it, we're just going to get the original instance back. So here we see we're asking for a Microsoft programmer. All this code runs exactly as it did before, and we can actually let's just go ahead and copy this up here. We can call this twice in a row, and everything's going to work fine. We're actually operating on the same class, even though we requested it twice. But let's go ahead and show you that this is true without you having to just take it for my word. So we're using the iCaffeinated interface. So we're going to go right here, and we're going to go ahead and add a property on this called drink count. All right. Well, let's go ahead. Let's see that with Mountain Dew. Do drink count. See, I get my type. All right. So go ahead and go into Diet Coke. And the same thing there. So now that we have that built, we can just say drink count plus, which is going to increment inside of Mountain Dew and Diet Coke each time this is called. So now we run this. Again, I'll run twice. The output. Let's go ahead and here you see we're calling iCaffeinated here and getting back a Mountain Dew. And then we're going to call it drink, and we're going to ask for it again and call it drink. And then we're going to write the drink count out to the console. So you see we have 2, which is great. It's exactly what we wanted. Now let's say that we are going to call this on a different thread. So let's say that we have public void drink caffeine. We are going to pass in an object, which is going to be our state. Let's go ahead and make sure we get this inside of our class. We are going to let's see, go ahead and define manual reset event. It's not triggered. We're going to wait on that. Let's see here. We're going to call drink caffeine method, passing in our wait event. And down here, we're going to cast our state to manual reset event. Set it. What we're going to do is we're going to call, we're going to go ahead and request our iKernel Ninject factory. Call drink on the result. So now what you'll see is we get 3 back. We're calling drink right here. Then we're queuing up a new user work item. We're calling this drink down here on a separate thread. And then we're coming back here and we're calling drink again. And when we write it out, we get 3 because we got one for each. We got the same object back for each request. But now if we go back, we change this. One per thread behavior, you'll see that we should be spitting out 2 when we run this. We are. But if we write out to the console here, the drink count, you'll see that we're going to have 1, and the other one gets 2. So we're getting a different instance inside of this thread than we are up here. And each of these are getting their own instance. So as you can see, this helps remove a lot of boilerplate code that you would have written. It allows you to easily implement singletons and per thread classes. Again, there's a 4th type of behavior called one per request that's used heavily within web applications. And again, that allows you to replace a lot of boilerplate code. Another good thing is that this allows you to remove your object lifetimes out of your application. So as we saw right here, all we did was change the Ninject configuration from singleton behavior to one per thread behavior, and without doing anything else, we ran our code and it took on the new behaviors. Well, I hope this helps you out using Ninject behaviors a little bit. I hope you enjoyed this screencast, and I hope to see you again soon. Thanks.